our losing class Wednesday, you're doing a more limited version of completing the square. What is our problem? All right. No, it wasn't. Completing the square is one of those things. I ditched it for a while, and now with the new standards, I need to bring it back. We are only doing a limited version of it. Children, I don't have... All right, completing the square. It takes some time and effort here, as well as I need to remind you, you know the quadratic formula today. So, completing the square comes from the idea, in a minute, we're going to try to make things be a perfect square binomial. By that I mean, in this case, x plus 5 squared. I want you to FOIL that and tell me, what do you get when you FOIL x plus 5?
X squared plus 10x plus 25.
And how did you know 10x is in the middle? The outers and the inners will both be 5x. If it's squared, the outers and inners will be the same. And so you'll always get double the amount in the middle. And then, of course, plus 25 on the end. So we know that pattern. Okay, well, I now want to go in reverse. What I want, when we say complete the square, I'm going to give you x squared plus 6x, and I'm asking you what number, like the plus 25 here, what number should be there so that this thing would turn out to be some perfect square binomial.
Plus 9.
Okay, why plus 9?
Because 3 plus 3 equals 6.
Okay, because we know the middle term is this 10x up here, it came from having a 5. So if you have 10x, you know you need half of it. So what's half of 6? 3. And then, up here, if I had half of 10 was 5, how did I get 25?
Divide by 5.
You square it.
Are you insane?
Okay. So what would 3 squared be?
9.
So plus 9 would be the magic number I need to make it be perfect square. Now, what quantity would it be squared? It'd be x
Plus 3.
Okay. The number you got when you took half, that's why I wrote it in yellow, that's the number you will put in there. Half of plus 6 was positive 3, and that's what you'll end up in your squared binomial. Okay, let's try about 52,000 more of those. Okay, what number completes the square by x squared minus 14x? What's half of 14? Technically a negative 7. Okay, now what goes in the blank though? You have to square that number. So what do you get?
49.
So it would be plus 49. Okay, what perfect square does it make? X. How do you know the plus or the minus? The 7. The number, the first sign in the problem. If that was a minus 14, half of it was minus 7, so you'll end up with minus 7 there. It's always whatever the first sign was. Of course, quantity squared. Okay, one more. And if you've already shouted out an answer, you can't this time. Okay, suppose I gave you x squared minus, what would be great? 22x. What would complete the square? Because half of 22 would be 11, and squaring it would be and it's always a plus because you squared it. Squaring anything makes it positive. So it would be plus 121. So what would be in my quantity squared?
X minus 11.
Very good. X minus 11. Okay. That's the process you have to be able to do what's called completing the square. So now let me show you how you actually solve a problem with that crazy thing. It's actually pretty cool that this works. Okay. I am going to give you x squared minus 8x minus 1 equals 0. Okay. I'm going to say solve that by completing the square. So this is another way, this is a third method for solving quadratics. When you complete the square, what we're aiming for here, in a couple steps, we want to get this down to being something squared equals a number. That's where we're going. Okay. Is -1 the right number to be sitting there? No, it's not. You don't like the -1, so you get rid of it. You kick it over to the other side of the equal sign and get it out of your way. So I'm throwing the 1 over on the right-hand side. I'm leaving the x squared minus 8x sitting here so that I can put my new best friend in its place. And so now, what number would be the number I would like to complete my square? Yeah, because half of 8 would be 4, squared would be 16. Now, here's the wrinkle. Can you just add a number to one side of an equal sign if you're solving? Yeah, you have to add to both sides. You have to keep your equation balanced. So if I added 16 to the left, I need to add 16 to the right. And then, yes, we can clean this up. The right-hand side is 17. Okay, the whole idea was that you made this trinomial be a perfect binomial squared. What binomial is it? X minus 4, quantity squared. Okay, now here, you did problems like this on that last quest you took. Those are the problems. Okay, how did we finish out? I had that quantity squared. How did I get rid of the square? Yeah. You remember we would take the square root of both sides and make that go away? Which would take me down to x minus 4 equals what? Yeah, plus or minus 17 is not going to break down. If it will break down, you should break down your square root, but that one's not. And so then last I need x by itself, so what do I do with the minus 4? You add it to the other side, put it first. So you have 4 plus or minus square root of 17. So how many answers do you have? 2. Technically you have 4 plus the square root of 17 and 4 minus the square root of 17. Okay, and here's an example of a perfect problem. You couldn't have factored that one. There's no way that one would factor, and there's no way you could factor and get answers like that. So if you're going to get answers that aren't very nice answers, factoring is not going to work for you. Completing the square is one option. So there would be our 2 lovely answers. That's not it for today. Rachel. No, it's not. All right, we are going to try one more because I have to show you one wrinkle. What's different about this problem than any of the ones I just showed you with completed square?
It's got a number. It's got a number. So you get something you can take out.
Yeah. And actually, yeah, you cannot, to complete the square, you cannot have a coefficient in front of x squared. That has to be 1x squared. Since that is not a 1, we have to get rid of it. And this is the one and only time I'm going to tell you, normally if you're factoring, I would say pull 4 out. In this instance, we have to divide the 4 out of there. So you'd actually have to go, oh, I don't want that 4, so I have to divide every single term by 4, whether it's divisible nicely or not. They all get divided by 4. So that's going to take you down to x squared plus 10x plus 70. Okay. So now what? What did I do next when I completed the square? Yeah, I got rid of the 70 because that's not the right number that should be sitting there to make a perfect square. So I ditched 70, threw it on the other side, it's negative 70. Now I get to fill in the perfect number. And I got a plus 25. Y'all buy it or not?
Yes.
What's half of 10? 5. Square that number is 25. And if I add it to the left, I have to add it to the right. So now, what perfect square binomial did you make?
X plus 5 squared equals
35.
Not 90. That's a negative 70.
Oh, okay.
That makes you have a negative 55. 45. Whoa, yikes. That's a little scary too. All right. So then, now to the end. Last but not least, how do I get rid of the square? You square root it. So I'm down to a lovely x plus 5. And, oh golly gee, could it be the problems from our last class? How do you simplify the square root of negative 45? You take out an I, you're correct. But you can break down 45.
9.
It's 9 times 5.
That's 3. 3 square root of 5.
Yeah.
3i square root of 5.
So it'll be 3i squared root of 5. One more. Thank you, plus or minus. And then last but not least, I need to move. Subtract the 5, and where should I put the 5? In front. So it's negative 5 plus or minus 3i squared root of 5. So this method, complete the square, will let you find imaginary solutions. You cannot find imaginary solutions from graphing or from factoring. They only come up here and in our last method. I will point out, how on a graph would you know you have imaginary solutions? If the answers were where, if the real number answers are where it crosses the x-axis. No. Does every parabola have to cross the x-axis?
No, it doesn't.
If a parabola does not cross the x-axis, then there are imaginary solutions.
So what do you think then?
So, well, normally on a graphing one, if they say solve by graphing, they'll say find the real zeros, meaning they want the real number answers. And if you can't get any real number answers, then you would say no solution, because they would be looking for the imaginary. But completing the square is one of the two ways that you can get your imaginary answers out. Okay, is that just a horrible, terrible thing?
Yeah.
Not that bad. Okay, then the one little thing I'm adding to I'm not making you do the most horrible, terrible of these. I could make these be nasty numbers, and I ditched that. So the problems you crossed off is getting rid of some of the ones that had nasty numbers in them. Instead, we're going to cut to the chase so that I can get you guys caught back up here before we actually lose our day. To the fourth and final method, which I think many of you have seen before, the quadratic formula. The quadratic formula solves any quadratic equation ever. If you're ever going to learn one method for solving quadratics, this would be the one, because it solves them whether they're factorable, not factorable, imaginary, real. It'll solve anything. Yeah, the factoring's way quicker. Factoring is way quicker. Factoring is way quicker. Okay, I'll tell you right now, most people will not use completing the square to solve. They brought completing the square back because it's going to help us. We do that process of completing the square in some other problems that are coming up in our next chapter after this one. So completing the square is useful. As far as solving a quadratic, you're probably not going to do it because factoring or formula are going to be faster. Pure and simple. I'm going to tell you to remember factoring and formula forever and ever. This formula I'm about to show you, I expect you to have to know all year at any time. Nope, you cannot. So if you have a quadratic in standard form, it will solve every quadratic. Now, what I don't have the luxury of time to do for you is, how did they come up with this crazy formula? Well, actually, if we do this problem right here, and we do completing the square on it, you get the quadratic formula. If you do the completing the square with A's, B's, and C's instead of actual numbers, you get the quadratic formula. So when you see this formula and go, oh, it's just completing the square. So, how many of you think you saw the quadratic formula before? Yes, most of us, but not quite all of us. Are you? Yeah. So Matt's the only one who doesn't think he's seen the quadratic formula? Okay. So, anybody remember how it starts?
Negative
Okay.
plus or minus the square root of b squared minus 4ac all over 2a.
That's it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. It looks horrible. And you may be sitting there going, how does that come out of completing the square? Well, if you do completing the square and you move the c over and then you add the number to both sides, you end up with fractions and you have to make common denominators and do all kinds of icky stuff to simplify it. But you eventually, you get this.
We should try that sometime.
I remember being very excited my first year of teaching when I discovered why the quadratic formula existed, because no one ever told me. I was like, oh, this is where it comes from. How cool is that? I just knew the formula. I didn't know why. Okay, you all need, however, to remember this formula. And so it seems to have improved since I taught people to sing the quadratic formula. Okay, so we're singing Pop Goes the Weasel. If you know Pop Goes the Weasel. Okay, so it goes something like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
I remember someone saying that last year.
Okay, so we're all going to sing very slowly. If you don't sing, I'll make you sing for the recording by yourself. So I better see lips moving. Here we go. 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Very good. Okay, I'm also going to tell you, Mr. Hermick is going to ask you to sing it to him next class.
No.
Because I'm going to tell him to ask you to sing it.
No.